If you've spent any time on the hardware hacking or gaming side of YouTube in the last 6 months, you're probably familiar with this. Now, you'll be forgiven for thinking that this is a graphics card, but it's not. It's actually a single board computer called the BC-250. Now, if you're already familiar with the BC-250, stick with me. This isn't a how to install Steam on it and play games. This is a I'm an idiot, I blew mine up, let's try and fix it. But for anybody who isn't familiar with the BC-250, it is essentially a single board computer, which if I just show you my other one, my broken one, I'll just show you this. It's a single board computer that's actually built using the APU from a PS5. Now, these are somewhat faulty APUs that didn't make Sony's quality control. But when you produce a chip like this, if it doesn't win the silicon lottery and it doesn't perform perfectly, it doesn't make the cut for the PS5, but it still physically exists. So ASRock came up with this idea to buy all the non-QC contending APUs and use them to build these mining rigs. So these were actually used for mining Bitcoin. Now, obviously, mining Bitcoin hasn't been profitable for quite a while. So about 2 years ago, these were considered e-waste. Now, if you've seen any videos on these recently, you'll know that people say, oh, you used to be able to buy them for $50 and now they were $75. They're about $150 or £120 at the moment. Me personally, I still think that's good value, but that's not what this video is about. But I was speaking to a friend of mine who actually bought a server rack version, the full Bitcoin mining version of one of these, and they have 12 cards inside. In April 2024, he paid $240 for a complete unit with 12 of these. So they were less than $50. However, people are tinkering about with them. I'm messing about with them. I, however, killed this one. So I'm going to, first of all, go to top down and I'm going to include my microscope in there. And I'm going to explain to you what I did wrong. I'm then going to explain to you how I diagnosed what I think is the faulty component. And then we're going to try and swap it. Now, given that just 2 videos ago, I practically obliterated the PCB on an Xbox controller, I'll put a link to that just up here, with the heat gun, I'm going to try and do this with the soldering iron, but the part is microscopic. So yeah, let's get into it. Let me show you what I've done. Let me show you how I broke it, and then see if you agree with the conclusion that I've come to as to what the fault is. Top down zoom. So I've got you in top down now. Just move some stuff out of the way that I don't need, like the mouse. Don't need a mouse for this. So this is the actual board of the BC-250, and if I just zoom you in a little bit, you can see here we have our I/O. So we've got USB ports, display port, USB 3 port, and a gigabit Ethernet port. We also have a power and reset button. You'll notice there we've got a little NVMe slot, and then we also over here we have the CMOS battery. We have how you power this device, which is via an 8-pin PCI Express power connector there. Sorry, the camera's a little bit dark. What we do have up here, and this is quite an important part of the BC-250, is we have this auto power on jumper and a clear CMOS jumper. Now, I've actually taken the jumpers off this, but essentially cover those 2 pins and the BC-250 will power on the moment you connect power to it. Now, that's the feature that I've managed to kill. Now, that's quite an important feature. Let me just explain to you why. So you will notice when we were looking at this board that there is no 20 or 24 pin ATX connector. It literally just uses PCIe 8-pin, not CPU 8-pin, so not the ATX 8-pin, but PCI Express 8-pin. So in order to get a power supply to be able to put power out to the PCIe 8-pin, it has to think it's turned on. So the way that we achieve this is we take the normal 24-pin ATX connector and we jump a 5-volt wire to ground. It's a specific 5-volt wire. I think it's number 4, maybe. Don't quote me on that, Google it. And you jump it to any ground. That tricks the power supply into thinking that it's turned on. The motherboard's told it should start delivering the rest of the power, and it puts power out through these pins. So what a lot of people do, I've used a simple connector here to bridge mine temporarily, but what a lot of people will do is they'll put a switch in here, like a latching switch or a toggle switch or a little flick switch. And when they flick that on, power supply kicks in, APU, BC-250 turns on. If you didn't have the automatic power on feature, what you would have to do is flick the power for your PSU, then go around the back of the board and hit the power switch. So you got to essentially flick 2 switches to turn it on, which is tedious. Nobody wants to do that. I certainly don't. So it has this auto power on feature on this jumper. Now, if you've ever been into your BIOS before, you're on a home server in a home lab, you've probably seen the auto power on after power fail type BIOS settings. It's exactly the same thing on this, but it is a physical hardware switch instead of a BIOS setting. The BIOS is actually quite basic on these. Plus, it's designed to mine Bitcoins. It wasn't meant to have monitors plugged into it. You weren't meant to be reaching around the back to push switches, and you certainly weren't meant to be plugging USBs in and going into the BIOS and stuff. You were meant to put power to a big 2U chassis and just let it mine Bitcoins. Now people are playing games on them. But I digress. So I've managed to kill the auto on feature. So the way this works and the way I've tested it on a working board is you're supposed to get 3.5 volts coming in here, and it goes down that middle pin. So I'm going to bring the microscope in. I'm going to get the multimeter out. Bear with me because I'm not an electrical engineer. 95% of what I've figured out here is pure guesswork. Although I have seen a couple of Joey Does Tech videos, so I'm pretty clued up, all right? Right, so I'm testing this view out. Normally I would just switch you to the microscope, but when the microscope is displaying on the PC, I can't see anything on the screen. It just goes into like a PC viewing mode. And because I'm going to be doing some tiny little soldering work, I need to see it, but I also want you to see it. So let's check out this view. So you can see I got the board here. You can see my camera is focusing on this, not on this. So I apologize. But if I take my multimeter, I put it in continuity mode, so it beeps. Essentially, you're just going to have to take my word for it a little bit, but this auto power on switch is normally jumpered between pin 1 and pin 2. And what that does is that tells the system you need to automatically power on the moment power is present. And I've killed that feature. So what I did, quite stupidly, if we come down here, we have a TPMS header, and I don't think that stands for tire pressure monitoring system. I think it means trusted platform module. Essentially, I was probing around looking for a 3.5 or 5 volt source that was available during main power on, but not available during standby. And whilst I was doing that, I noticed that this pin was a ground, and I think this pin here, maybe potentially number 3 or number 4, was the sort of pin that I was after. It only supplied voltage when the system was running. It didn't supply voltage during standby. However, as I was putting on my ground lead, I accidentally shorted this pin here. I got a nice little spark, and I thought I dodged a bullet. I thought everything was fine. I unplugged the power supply, I disconnected power, I drained the residual charge, put the power supply back in, everything seemed fine. Then I realised it wasn't auto powering on anymore. So I was like, oh, I've broken something. So what I then started doing was I came back up here to the pin header for auto power on, and I started probing around. And I also then took my working one and started probing around as well. And what I quickly discovered was, as I say, we got voltage on this pin during standby, and then we got voltage going down here. I noticed that when the system was powered on, I actually got voltage on this pin. But when I shut the system down and it went into standby, I lost all voltage on this. So I tested on my working one, and the working one has voltage on the pin during standby and power on. So I thought, I have no idea what I'm doing. But if I put it in continuity mode and I start poking around, first thing I did was I probed the middle pin to try and find out where power was supposed to be going. And I traced it all the way down to this chip here, which is a, what does it say on there? Let me see that. It's a Nuvoton, there we go, Nuvoton, a bit like those knockoff Louis Vuittons. It's a Nuvoton, and I noticed that when I put my probe on the middle pin for auto power on, and then I just started scratching around the board, I noticed that pin 4 on here is expecting that voltage. So I was like, okay, cool. I know where it's going, and the path to where it's going is intact. That was quite important for me because I was worried I'd popped a trace or something. This is a multi-layer PCB as well. Thankfully, I don't think that's relevant right now. So then what I did, I came back up and I started probing pin 1 to try and find out where that power was supposed to be coming from. And whilst I was scratching around the board, looking for where that was coming from, I came across this section here, which if I can just focus in a little bit more for you. Hopefully see that there. And I came across this little guy here, and it is tiny. Like the points of these probes are like needles. So it is absolutely tiny. But I noticed that I think it's pin 1 on here. Yeah. So pin 1 on here is what is connecting auto power on pin 1 to the rest of the system. So something's going on here, but the path between auto power on pin 1 and this little chip's pin 1 here is intact. You can hear that clear as day. So then I started probing about elsewhere, and I figured out that this little bottom leg here is ground. So you can hear that, so that's intact. And I was thinking, well, if this is like a MOSFET, maybe there's a drain on here. So I connected my probe to here, and again I just started scratching around. It's not a ground. I tested it on a piece of metal, and I noticed straight away, okay, well, it's not a ground, maybe it goes somewhere else. So I was probing around the top part of the board, so this bit here, and I immediately found, so if we just go back to this little chip here, so I'm going to go back on this little leg here. Which one on there? Yeah, on that leg there. So I just started probing around, and I found this capacitor just here, I think. Is it on here? Yep, there. I found that. I was like, all right, okay, so it's something to do with this. And then I started probing around a little bit more, and I got to this MOSFET here that you can see. And I found out straight away that it is connected to the drain on this MOSFET. So you can see that there. And I was like, okay, cool. So this MOSFET's doing stuff. I was like, it's coming through here and it's going essentially to my auto power on pin 1. So I was like, cool. Well, in order for me to know what this MOSFET's meant to be doing, I kind of need to power it on. So I'm going to do that with you now. So if I take my power supply, I'm going to connect the 8-pin connector into the bottom of the board just here. I'm then going to temporarily pop the heatsink back on. You'll notice this heatsink looks a little bit different. It's because I've cut off the fins so that I can sit a 120mm fan on top. If I sit this heatsink back on here temporarily, I know it needs repasting and everything, but this will do for a demonstration. So if I hold this down for a second and I put power in, now you might notice, in fact, I'm going to have to put without the jumpers on, so without the clear CMOS jumper and without the auto power on jumper, it does automatically power on, but it doesn't post, it just powers on. So I'm just going to connect this in, and you'll see that it's powered on. So I'm just, but like I say, it wouldn't post. If I connected this to a video out, I wouldn't even get BIOS, just black screen. So I'm just going to press and hold the power button, just to hard power it off. There we go. So that's powered off now. So it is in a low power state. So it's almost like standby mode. So if I then take the cooler back off, just because I didn't want to start it without it, pop that out of the way for a second, we can now start probing around and try and figure out what this MOSFET is supposed to be doing. So if I flick my multimeter, in fact, let's see if I can get the multimeter in shot. I don't think you're going to be able to see it very well. But let's see if I can get that in shot. So if I switch my multimeter to voltage DC, we come back to this MOSFET, which hopefully you can still see on screen. So I was probing around, had this connected to ground, and then I thought I'm going to check the source on the MOSFET. And I could see there straight away I'm getting 3.5 volts. I'm getting logic level voltage. So I was like, cool, okay. Well, now that I'm in standby, am I getting any voltage on the drain? No. No, I'm not. I'm getting 0.091 volts. So then I was like, well, okay, so something must be signaling this. Am I getting any volts here? It's like, oh no, minus volts. That was weird. I was like, okay, what's going on here then? So I flicked it back to continuity mode for the beep. And I put it to ground. And I probed it again down here. And it's a ground. I was like, okay, weird. That wasn't a ground when I was testing it earlier. So when I was probing around with no power to the board, that wasn't a ground. I definitely checked that. So I disconnected power from it. And I came back in here with my continuity mode. I probed this again. Nothing. It's not a ground anymore. So I was like, all right, okay. What on earth does that mean? So I started doing some research, and I believe it's known as a P-channel MOSFET, which essentially means that it has, if I just show you here, so it has a source, which is this top pin here. It has a gate, which is this one here, and then it has a drain. Now you'll have to forgive me, as I say, I'm not an expert in this, but my understanding of this specific P-channel MOSFET is you have incoming power on this here, on the source, providing that the this is where I'm getting confused now. So providing that the gate voltage is less than half of whatever you've got on the source, it will open up and it will allow power to flow down to the drain. So if you think, if I've got 5 volts on there, and then on my gate I have 2.5 volts, that's less than half.
2 + 2 is 4, -1, that's 3, quick maths.
Less than half, so it should open up, it should let the 5 volts through. That's kind of my layman's understanding of it. The surefire way to make sure that you have less voltage than your source is to just drop your gate all the way down to 0 volts by going to ground. So that means that no matter what's sat there waiting at the source, it's less than the gate, therefore it will be allowed to the drain. Kind of. Somebody in the comments, please correct me if I'm wrong, but that's how my simple brain understood it. So the fact that when I am in standby, that is a ground, that tells me that whatever is meant to pull that down to ground is working perfectly fine. I didn't damage that when I shorted those pins. However, given that that is ground and it's not letting my source go to drain, that tells me that that's kind of where the problem is. That's the logic I came to. That's the conclusion I came to. And that's the only thing I can think right now. What's also interesting as well, and I haven't been able to test this theory because I didn't power it on without the heatsink on, but I would love to know, and I suspect that during normal power on, the gate on that little P-channel MOSFET is not ground. I think the way the system works and the way the power control works in this system is when it switches from full power to standby power, some circuit in the Nuvoton switches that P-channel MOSFET to say, okay, you're on standby power, you're supplying 3.5 volts to the standby circuit. When the system turns on, I think that switches again and goes, don't need you right now, I've got power coming from somewhere else. So I think it's a very clever standby circuit switch, I think. So thanks to the power of Amazon next day delivery, I have 100 of these. At least it says it's 100. I'm not about to count that. But I apparently have 100 of them. So I'm going to try and replace this, and I hope that fixes my standby power issue. Because I've printed a really nice 3D case, I've tested this, I've played some games on it, it works really well, I'm really happy with it. Then I killed it. So yeah, I'm going to try and desolder that now. But given my last experience, as I said, I'll put that up here. Given my last experience using a hot air gun, and given how many tiny components, if I just lift this microscope up a little bit, focus, you can see just how many tiny components there are there. And I'm just going to put a finger in there for scale. So you can see that there are lots and lots of tiny components in there. I'm not going anywhere near that with a heat gun. So instead, what I'm going to do, I'm going to take my knife tip for my soldering iron. I'm going to try and flood the area with solder. I'm going to try and solder wick this pin. So I'm going to try and solder wick the drain. And I'm going to hope that I can get both of these at the same time and just pick it up and lift it off. We're going to see. If it works, it works. If it doesn't, it's already broken, isn't it? That's the best way to look at it. I can't make it any worse. I can absolutely make this worse because at the minute it works, kind of. It boots, it posts, it still plays games. But I don't want to turn my e-waste, well, it was e-waste, then it got a purpose, then it came to me, and now it's e-waste again. So I don't want it to stay e-waste. I want to fix it. So that's what we're going to do. So if you bear with me, I'm going to get my soldering stuff set up. Oh, I'm going to get my mat because I know it's just my luck that I will melt this desk pad. So I'm going to get my silicone mat. I'm not looking forward to this. Okay, so I've got my silicone mat. I've got my microscope. I can see the microscope. I hope you can too. If I tilt this just towards me just a little bit, Can you still see it? Yeah, you can still see it, can't you? And I can see it great. So, right, what did I say I was going to do? I'm going to try and get this off. Look at the end of my tweezers on there. These are tiny tweezers, or tiny pointed tweezers. And I need to get that off. Okay. I have no idea what I'm doing here. But we're going for it. So I'm going to put a little bit of flux on here. He says as he puts lots of flux on there. I'm then going to take the last of my low melt solder. That's all I've got left. So if we don't do it in this, we are pooched. And I'm going to put that on the drain of this MOSFET. So we're up to temp. The reason I'm going to put this on the drain is so that it just lowers the melting temperature a little. Because this is decent. It's always been good solder to me, is this. But I'm doing that so that I can then come in with some solder wick. And hopefully get all of the solder off of the drain. So I'm going to do that. Bring this in here now. Don't know if that worked or not. I'm going to hope it did. Let's see if we can lift that up slightly. Nope. Okay, let's see if I can lift this ever so slightly. Oop. Oh, I think I felt that come up then. Oh, yeah, is that up? Is that lifted up? Can we see that there on the microscope? I think it's still attached, but it definitely lifted up. Okay. Well, let's see then. If I come in on the other side now, can I lift this up? Do you know what I'm going to do? I'm going to spin the board, purely because I'm coming in at a funny angle for the capacitor that's just sat just next to it. So if I take this, where is it? There it is. Okay. So let's see. I take this, just because I was wrestling this cap in the other orientation. So I take this now and I put this just on here. Don't want to pull too hard. Oh, that was just the tweezers letting go. Oh. This is a very tight gap. So what I'm going to do, I'm going to put some more of my solder. I'm just going to put it on these points here. There we go. Okay. Let's just see. Okay, I think that's in the air. It's difficult for you to see there, but that is in the air. Okay. Let's see if we can cock for the other side of it. Wherever that's gone. All right, there we go. That's where that mess is that I made. That's fine, we can tidy that up. So that should be in the air now. So if I grab it with the... Oh, is it coming off anyway? Don't want to pull it. There we go. That is tiny. It's the tiniest thing I've ever seen. That's what she said. So let's take that, put that in there. That's going to be my little trophy pouch. It's not going to be. As soon as I hang this back up, it's going to fall off. Right, okay, so now that I've done that, I'm going to swap out soldering iron tips. So I'm not a massive fan of this one, but it served a purpose. I'm going to go back to my favourite, which isn't that one. Where's my favourite one? We all have a favourite tip, right? I'm just going to flux the board up a little bit more. I'm just going to come in and wick away that solder. So if we come back in here, I'm just going to clean up these pads. They look fine. Yeah, they look great. Cool. I am then going to get my toothbrush and some isopropyl alcohol. Isopropyl alcohol. Let's give this board a quick clean. Beautiful. You'd never even know I was there, apart from the missing component. Move this to one side. So these, I don't know if you're going to be able to see these under the microscope. These are the 100 replacements that I bought. These are a slightly different spec. I can't remember the model number of these. I'll put it on screen somewhere. I'm also not going to count to make sure that I got 100 of them. I'm just going to hope for the best. But if anybody needs any of these, I've got 99 for sale. Actually, I might have 98 or 97 for sale, depending on how this goes. But let's just try and get this out without dropping it onto the carpet. So if we just tip this there. And if I grab that, you can kind of see it on the microscope there. Ooh. So there is our replacement, and I need to make sure that I get it the right way around. So if I flip that, which side's got the model number on? See, that to me looks the right way around. Yeah, I think that's got to be the right way around. Anyway, let's flip it up. Yeah, that is the right way around. So I'm going to just pop that on my pad for a second in the correct orientation. Oh. Yeah, okay, cool. So what I'm going to do, and I've no idea if this is the right way of doing it, but I'm going to take a little bit of solder and I'm going to put it on the drain pad, purely so that I can try and line up the other ones. So I'm just going to come in here, a little bit of solder on that pad, like that. And then I'm going to take my tweezers and the component without yeeting it everywhere. Oh, it does have some writing on it. It says A19T. If you're wondering what it is that I'm fitting, it's that. So what I'm going to do now is holding this. Come on. Do you know what? I've watched Joey from Joey Does Tech for years, and watching him manipulate those tiny little solder balls when he's manually reballing something, honestly, such a skill. I've got such an appreciation for that, because this is very difficult for me. Okay. Don't flick it everywhere, Steve. Come on. I hope this isn't difficult to watch. Just forgive me. Just know that I'm doing everything I can to make you all proud. Let's have a look. Come on. Just go home. You want to be there, don't you? Right, I'm going to get my soldering iron. I'm going to get it up to temp. And I am going to, hopefully, surgically lift this into place and tack the drain. No, stop lifting. Why is it top heavy? Why is it so top heavy? Come on. No. I've flipped it upside down. It's like a turtle on its back now, I think. No. Right. Why is it so top heavy? Every time I pick it up, it kind of just like pivots. Pivot. Pivot! Come on now. Come on. If flux and a heat gun, I know it would have probably just fallen into place. No! Son of a mother lover. Come on. Would this be easier if I put loads of flux on the board? Would the flux hold it in place? I don't know. Right. Come on. Is that close enough? Okay. Right. That is the gate is soldered. The drain is soldered, sorry. Oh. Ooh. Right. I'm just going to apply a little bit of pressure on the top as I heat that up again. Yeah. Sweet. And those feet are perfectly aligned. If I feel like being deceitful, I'm going to edit this so it looks like I did it straight away. I didn't do it straight away. If I left it in and you struggled with me, you're the real one. You're the real OGs. Right, let's see if I can get this soldered in now. And this one. Hey. Hey. Hey.
Look at us. Hey, look at us.
Look at us. Huh? Who would have thought?
Not me.
I mean, that to me looks like that's in there. We'll do some testing. As soon as I clean the board while it's still warm. Just give the board a quick clean. See if this comes off, because if it falls off, I shouldn't have left it on there anyway. Hey, look at that. I do say so myself. So a multimeter. Let's just do a quick continuity check to make sure that the drain on that is still going to the teeny tiny little chip here. Ooh, that's a good noise. Now I need to put it back together, or at least I need to put the heatsink back on to power it on to see if I'm getting my voltages. So just give me 1 second whilst we do that. Because I need to pop the heatsink back on. Heatsink back on, 8-pin PCIe connector in, power supply on, and it's powered on, which it does anyway because there's no jumpers on. I'm going to press and hold the power button to turn it off. Takes it a minute. Cool. Right, that's off. I'll just leave the heatsink on for a second, just so it was quite a lot of residual heat last time. Sweet. Right, so take the heatsink off again. Pop that out of the way. So, with my probe, moment of truth time. with continuity again. Is our gate still grounded? This is looking good. Switching it to voltage mode. Let's put it into voltage. Move the power supply unit out of the way. Bring this in. So if we go to voltage DC, and I probe, let's probe the source. I've got 3.4 volts. Moment of truth. 3, 2, 1. We have got voltage on the drain. Just to show you that there, we've got 3.4 volts on the drain, which means, in theory, if I've understood this circuit right at all, if I come over here and I probe auto on pin 1, we should have 3 volts. Or 2.5, which is fine. 2.5 is what I read on my other one. So we now have 2.5 volts down there. That means that by replacing this little component here, oh, why is that moving? Is that moving? Why is the flux doing that? I don't know if you can see that on camera. When I do that, the flux kind of moves. Weird, but that seems solid. Anyway, Steve, stop probing about. That's how you blew it up last time. So yeah, if I go to ground and I go to pin 1, I've got 2.5 volts again, which is exactly what I'm supposed to have. So I fixed it. I managed to fix a standby power circuit. So if you have a BC-250 and if you are as stupid as me and you manage to blow this and stop your auto power on from working, check that P channel. Is that what I called it? P channel MOSFET. Check that. And hopefully that sorts it. So what I'm going to do now is I'm going to get the thermal paste reapplied. I'm going to get the heatsink back on. I'm going to get the jumpers put on. And we're going to make sure that this actually auto powers on like it's supposed to do. The jumper in the CMOS settings position. And I'm going to put this other jumper in the auto start and auto power on position. Now it's worth noting that first power on, it always kind of seemed to just power on. It was consecutive power ons after it had a little bit of charge in it that just didn't work. So let's check what's going on. What have we got here? I need a video cable, so I'm going to put DisplayPort in there. I need a USB cable for my keyboard, so I'll put that. Put this one in here. Oh. And then into the keyboard. I'll just borrow my desktop one for now. What else do I need? Power. And then I'm just going to switch my camera to like game capture because that's kind of what I've got this plugged into at the minute. So you won't see anything on screen at the moment. In fact, no, I'll leave it on top down for now. Sorry. Leave it on top down. So if I put power in, you will see straight away it powers on. It's in the BIOS. It's not posted yet. It's not finished post yet. So we should be able to just power it off as soon as it gets its life together. Cool, so it's powered off. So the real test now of whether my fix works is, well, first of all, let's double check. Are we still getting voltage? So if I put this on a ground and I come over here to pin 1, we're still getting 2.5 volts. So that's fantastic. That's what I killed earlier. So now, if I pull power, so it's kind of in a standby state at the minute. If I pull power and I put power straight back in, power's back on. Beautiful. In fact, because that's worked so well, I'm going to treat it to something. I'm going to treat it to a new CMOS battery. So we'll put that in there. Let's see if it auto powers on again still. Nice. So I'm going to switch to game capture now. Okay, Steam logo, progress. Well, hey, I need a controller now. Switch Pro controller, turn this on. Is it still going to pair? Yeah. Way. Okay, so I don't want to turn this into a BC-250 video, but we need to make sure it works, right? So if I go to Baldur's Gate, I don't know why it shows 655% GPU utilization. Don't know. Okay, so for those who know the game, we're just in the beginning. But let's go outside and see. Let's get it warm, basically. So that's working for all intents and purposes. Obviously, you can still hear the game, I think, so I'm just going to mute that. So yeah, that's the BC-250 fixed, I think. Let's wrap this up. So there you have it. We've actually managed to fix my BC-250. And I think, to be fair, that's my first ever bit of what I would consider micro soldering. So hopefully I did okay. Certainly not as bad as I did with my Xbox controller. But yeah, we're just going to forget about that. It's in the past. That was like 2 videos ago now. So yeah, the BC-250 is fixed. I've 3D printed a case. I'm going to get it all thrown together and I'm going to sit and play some games on it, to be fair. I've been threatening to play on Twitch for a while. So if anybody fancies watching me on Twitch, let me know in the comments. I'll see what I can do. If not, I'm just going to plug this in the living room. The idea with the BC-250 for me is it's a portable gaming PC, or it's a portable thing for playing PC games on. So the idea is PC games on the sofa kind of thing. I have a decent desktop sat here, but I work from home sometimes and I spend a lot of time sat here. The last thing I want to do in an evening is continue to sit in the same room I've just spent all day in. So yeah, I thought this would be an ideal little thing. So plus I love tinkering. And like I said, I did buy 2. I've got a second one. Thankfully I bought 2 because I know what I'm like. I knew I was probably going to break something. So yeah, we fixed it. Micro soldering, done. Tick that box. I'm not going to get cocky though. I know that was a fairly easy one. There wasn't a lot of stuff around where, or directly within the vicinity of what I was doing. So I think I got lucky. I got real lucky. But I also think I did okay. Quite proud of myself. So yeah, if you enjoyed this video, if you want to see more of the BC-250, let me know in the comments. There's a lot of stuff on there already. Tito from Macho Nacho's done a really good video on it as well. But if you want to see what I'm doing with it and you want to see me tinkering with it, drop me a comment, let me know. I'll try and do some videos. If you feel inclined and you enjoyed the video, please smash that like button. And if you're feeling really generous, hit subscribe, because that there number goes up. It gives me warm fuzzies inside. So yeah, thanks for watching. Hope you enjoyed the video.